I'm Camille and this is Chem with Chem. Now in today's session we're continuing with our learning series on addition versus condensation polymerization. If you missed the last video on polyamides, then be sure to check the link in the description below or the card above. Now, the number one tip we're giving today for studying is exactly what's wrong with probably this picture. Do not study in your bedroom. Now, your brain has associated being in your room with sleeping. So naturally, when you're there, your brain is going to be telling your body it's time to shut down. So do not study in your bedroom. Go somewhere else, find a table, ensure that it's nicely lit, properly ventilated, and you just get to work there. All right, so if this is your first time to the channel, welcome. And if you're a returning viewer, then big up yourself. All right, so let's just get right into it. Polyesters now, so we know that the linkage here would be the ester linkage or the ester bond. Sometimes this is represented as COO, like that. So both of them can be, well, it can be represented both ways. So we could just probably just move these from beside each other so they're not confusing. So that's that. So can be written as this as well, COO. All right. So polyesters are synthetic fibers and they're made as imitations of natural materials like wool and cotton. So if you check the tags of your, some of your clothing items, some of your items of clothing, you'll see 65% polyester, 35% cotton, and so on and so forth. So how does this work? Now, if you understand polyamides, how those are formed, then it's a similar reaction here. Again, condensation. So we're gonna look at what happens in our terylene. Terylene is also a polyester. Yes, so that's the example that we're gonna be actually looking at. So we have again a diacid. So we would have C double bond O OH. And we will use X again, which is a variable hydrocarbon group. We're going to point out what the group is, so those from those who are doing CAPE can actually benefit as well. For CXC, we just need a representative. We can just put X right there, and that will be fine. All right, so in terylene, so this is our diacid again. In terylene, T-E-R-Y, in terylene, X is C6H4. All right, and then we have dialcohol. So of course, when we get to get an ester bond, generally it's an acid reacting with an alcohol. But for the polyester here, we're going to be having a diacid reacting with a dialcohol. So we'll have our alcohol, and we'll have Y being a variable hydrocarbon group, and we have 2OH, and then of course in terylene, Y is C2H4. So we're just going to go straight into what happens when these join, so we can get the representative structure of the polymer, the polyester here, terylene. So of course we would start with our acid. We don't have to, but since I wrote it first, so we'll have our acid beside our alcohol. And of course, again, it's the OH from the acid and the H from the alcohol, and that will come off as water. And then the representative structure Because if this were to happen again, we would have the OH from a neighboring, the OH from a neighboring acid would always go with the H from the alcohol beside it. So when we're doing the representative structure, we can do it like this. If we're starting with the acid, we would just write a line to represent the bond after having taken off this OH. So we'd have C double bond O, then X representing the variable hydrocarbon group, then we'd have C double bond O, and then we have this other O now, which is coming from the dialcohol, which we're going to put in blue so we can see where they're coming from. And then we'd have the Y, which is the variable group in the alcohol, or the dialcohol to be more specific. And then after that, now we would have our O, and we'll leave it there, and then we'd have a bond, or what we call a sticky end. Now we put this in bracket, and we put an N around it, and this is representing the structure of terylene, which is a polyester. Of course, this is the bond, the linkage here is the ester linkage, so we highlight it. So this is the ester linkage. And it can be written as COO bond. All right, so here it's bond, ester bond. So that's pretty much it for polyester. According to syllabus, we just need to be able to give a representative structure of terylene. For those who are doing CAPE, you are required to know what the variable hydrocarbon group is at X in your diacid and at Y in your dialcohol. And just like that, we've come to the end of today's session. Be sure to check out all the other material that's here on the channel. Leave a comment, give a feedback, share with a friend, and consider subscribing if you have not done so. All right, couple later.